Welcome back. In the first three modules of the Asset Intelligence Framework, we focused on the financial and strategic layers. But now, we are going to the shop floor. We are talking about the reliability blueprint. As an expert who has spent decades in manufacturing and utilities, I have seen the same mistake repeated thousands of times. Companies trying to automate their way out of a bad maintenance plan. If you automate a mess, you just get a faster mess. In the AIF, our first rule is absolute. We simplify before we optimize, and we optimize before we automate. Today, I'm going to show you how to build a blueprint that eliminates unplanned stops without drowning your team in unnecessary paperwork. A blueprint isn't a list of things to do. It's a strategy for what not to do. Most plants are burdened with the legacy PMs, tasks that were added 10 years ago because of a one-time failure and never removed. This is institutional waste. Before we talk about sensors or AI, we perform a criticality audit. We look at every preventative maintenance task and ask, what is the specific failure mode this is preventing? If we are greasing a bearing every week just because, but the wear rate data shows that bearing only needs service every 6 months, we are actually creating a risk. Every time you open a machine, you risk introducing contaminants. The AIF approach is to strip the blueprint down to the studs. We remove every redundant step, every visual inspection that doesn't lead to an action, and every task that doesn't have a data-backed reason for existing. We simplify the workload so the team has the time to do the important tasks perfectly. Now let's be realistic. We talk a lot about intelligence, but that doesn't mean every single motor in your plant needs a wireless vibration sensor. That isn't smart management. That is over-capitalization. The Asset Intelligence Framework uses a balanced approach. For your Tier 1 critical assets, the ones that stop the whole plant, we invest in the sensors. We want real-time health data. But for the Tier 2 and Tier 3 assets, we use data-driven periodics. We look at the history, the wear rates, and the manufacturer's physics-based limits. If we know a filter in a processing line hits its pressure limit every 500 running hours, we don't need a $5,000 sensor to tell us that. We schedule it. The intelligence in the AIF isn't just about the technology. It's about the logic of knowing which asset gets which treatment. We eliminate the firefighting not by over-instrumenting, but by having a plan that respects the physics of the wear and tear. The goal of the reliability blueprint is the total elimination of the emergency. Firefighting is the most expensive way to run a business. It's 4 times the cost of planned work, it's dangerous, and it kills your die for it. To stop the fires, we focus on standardized execution. Once we have simplified the tasks, we make sure that they are performed the exact same way every time. We use precision tools, laser alignment, calibrated top wrenches, and filtered lubrication. If we can't put a sensor on an asset, we use the operator's intelligence. We train the people who stand next to the machines for 8 hours a day to recognize the early signs of drift. Reliability is a team sport. The blueprint is the playbook that ensures everyone knows exactly when to pause before a failure becomes a disaster. Let's look at a model scenario in a processing plant. They were suffering from 3 major unplanned stops per month on their primary centrifuge. Every stop cost them $25,000 in lost product and emergency labor. The team's first instinct was to buy a redundant $300,000 centrifuge. Instead, we applied the Asset Intelligence Framework. Step 1. Simplification. We audited the PMs and found that overgreasing was actually causing the seals to fail prematurely. We deleted the weekly grease task. Step 2. Optimize. We analyzed the wear rate of the internal blades. The data showed that they reached a critical wear point every 4 months. The result? We moved to a strict 3.5-month precision exchange, no sensors, just good old-fashioned wear rate planning. The unplanned stops went to zero. They saved $75,000 a month in downtime costs and avoided the $300,000 capex for a new machine. They achieved world-class reliability by simply understanding the life cycle of the parts they already had. Your homework for today. Take the top 5 maintenance tasks your team performs every week. Ask them, how many of these actually prevent a breakdown we have seen in the last 2 years? You will likely find that 2 of them are just ghost tasks. Simplify them, remove the waste, and start building your real blueprint. In Module 5, we'll talk about root cause physics, how to ensure that when a failure does happen, it's the last time you ever have to deal with it. I'll see you there.